Up until now, I've used JPA to map a database record to a special type of object called an entity using Hibernate as the JPA provider. This was great when working with a single targeted record and its associated data. You'll probably at some point still need to query the database for a set of records. To do this, you can use a JPA query. You know by now that a query in the database is often a select statement of some kind, but can also be an update, insert, or delete statement. In JPA, you have three options to execute a query, all of which still rely on the existence of an entity class. You can use a JPA query using a special query language named JPQL. There's something called a criteria builder, which is a more programmatic way to put together the selection request. Finally, if you're comfortable in SQL, or maybe you have a special need to increase performance, for example, you can still use a native query which relies on SQL. The Java Persistence Query Language, or JPQL, is an object-oriented query language. It's specifically designed to work with entities in Java applications that use JPA. It provides a way to query data stored in relational databases without needing to understand the details of how the data is actually structured there. Let's start by looking at JPQL in some code. I'll be using the same project from the last couple of lectures, so I've got the JPA project open. Using this project means I can continue to use the entities, artist and album that are set up previously. To use JPQL, you actually query entities and not tables specifically. I'll create a new class in the dev.lpa package and I'll call this class mainQuery. I'll include a main method using the PSVM shortcut. Before I add any code to the main method in this class, I'll first create a private static method also in this class. This method is going to return a list of artist entity types based on some query. So I'll start with private, static, then list with artist declared in angle brackets, so my list will only have artist entities in it. I'll name this method getArtists JPQL. We'll have two parameters. First, an entity manager, which I'll be creating and managing in the main method and passing to this method. I'll also include a string, which I'll call matched value. So next, I'll create a variable, a string for my query statement. I'll call this JPQL and I'll set that to a string literal. Select A from artist A. This looks a lot like SQL. The letter A in this case is a variable as well as a table alias. Notice that I'm selecting not from artists or music.artists, so not from the table name. Instead, I select from artist with a capital A, which actually refers to my artist entity, the artist class in other words. I can execute this query using a method on the entity manager. I'll use local variable type inference to set up the next variable, so var as the type and query as the variable name. I'll make that equal to the value I get back when I execute create query on the EM method argument, which is really an entity manager. This method takes two arguments. First is a string that contains JPQL, so I'll pass my variable for that. The second argument specifies the class name of the entity that's being queried, so here I need to pass artist.class. Finally, the query object I get back has a method called getResultList on it. In this case, it'll return a list of artists, so I can just return that directly here from this method. And that's that. These three lines of code will get all the artists from the music schema from the artists table. Before I run this, notice from IntelliJ's inlay hint the type that's inferred for the query variable. It's a typed query, a generic type, an interface in this case that has a type argument of artist. I can control-click on that hint. This opens up a decompiled class file in a new tab. There are tools that will take a class file and decompile it into source code, which can show you quite a bit of the implementation details. In this case, I can see this as a typed interface that extends query. If I hover over the name, typed query, I can see that this interface is part of the Jakarta.persistence package. I'll pull this interface up in the Jakarta API docs. To find this link on your own, just Google the terms Jakarta and typed query together to find the latest version or most current version you can. I'll scroll down a bit on this page so you can see the list of methods declared on this interface. You'll see at the top of the list there's the getResultList method, which I'll be executing in this code. This is followed by getResultStream, which returns a stream of the entity type. You know I like streams, so this method could be particularly useful for using stream operations we've become pretty familiar with. This will let us quickly investigate or manipulate query results. Let me give you a word of caution though. You want to avoid, if you can, using a stream to filter or limit results, though it might seem simpler. It's usually a good idea to limit data going across a network. If you can add the criteria to the where clause of the JPQL query that gets executed on the server, you'll be better off than trying to filter the stream on the client side. But you can imagine using the stream result to create some sort of mapped collection based on column values in a table as they're translated to entity fields. I'll be showing you an example of this in a little bit. There's also getSingleResult, so maybe you only care about one entity, though several might match your query. For example, if you've got a sorted query, you might only want the first record, sometimes called the top, and this method limits the data returned to a single record. There's a couple of useful set methods, and then a whole series of set parameter methods, as you can see. Getting back to the code, I'll run my first JPA query. To do this, I need to add some code in the main method. I'll set up a variable for the results from the getArtistJPQL method, so a list of artists, and I'll initialize it to null. Like I did previously, I'll first instantiate an entity manager factory from the persistence type within a try with resources declaration. I'll pass it the name of my persistence unit. Hopefully you'll remember I set this up in the persistence.xml file. In this case, the persistence unit is named dev.lpa.music. Next, I create an entity manager instance using a method on the factory. Again, this is still in the try with resources declaration. I'll get back to the code that goes in the try block in a second. I'll just complete the statement with a catch block, printing the stack trace of any error I get, ignoring IntelliJ's warning that this isn't very robust handling of a problem. My variable, artists, will get set to the result of calling my getArtistJPQL method. When using JPA queries, it's a good idea to wrap the queries in a transaction. I'll get a transaction from the entity manager. I'll call transaction begin next. I need to pass the entity manager variable and then a string, and I'll just set that to an empty literal string to start. You might have noticed I never used a second parameter in my method's code block. I plan to change that code shortly to use it. Finally, I'll print the results I get back. I can use for each on the artists list variable and a method reference to print each artist that's in this resulting list. I'll call transaction commit here at the end. You might be wondering why you need a transaction when you're just querying records. This is kind of a complicated subject and has to do with lazy loading versus eager fetching of dependent tables, as well as transactional integrity between related tables. If you do have problems with your queries and you're not including them in a transaction block, let me recommend trying this to start. Now I'll run this code. So you'll see in the output all of the artists in the table. In my case, that's 202 artists that get printed. Each record contains all the row data in each artist record, so that's just artist ID and artist name. Notice though that each record also includes all the artist's album records. In my JPQL statement, when I specified select A from artist, I didn't specify what data I wanted, meaning what fields that map to columns. So it returned all the data for all the fields on this entity. You recall that I set up the entities by declaring a relationship on the albums field, a list declared in artist to the album entity. All of the underlying database querying with the appropriate joins was done seamlessly by the JPA provider, in this case Hibernate. This means I'm able to write a very simple generic query against an artist entity class to get related data, in this case albums, for each artist. This doesn't require the developer retrieving data to know anything about inner or outer joins or foreign keys or any other specific implementation details of the database. It also doesn't require views on the database server for simpler querying of a normalized schema. You may still want to employ those techniques, but in this case, none of that is necessary in the operation of this query. This might be a welcome relief if you don't want to deal with databases directly. Now, I'll alter the query slightly, this time just getting artists whose name contains STEV. First, I'll change my select statement. I'll add a where clause, so I'll append the text where a.artist name, like :partial name. In this case, you can see I'm using the attribute name on the artist entity and not the column name in the table, which is artist_name. My placeholder parameter, which is called a name parameter in this case, is specified by a colon followed by any variable name I want. So here, I'm calling it partial name since I'll match on part of the artist's name. Next, I need to actually pass a value to this placeholder parameter. So I'll add a call to a setParameter method on the query variable. One version of this method takes two strings. The first is the name parameter, so I'll pass partial name as a string literal. The literal value should match the name parameter used in your JPQL statement. The second argument to the setParameter method is the value to be used, so I'll pass it the matched value, the method argument that contains the criteria to match on. Back in the main method, I'll change how I invoke this method. Instead of passing an empty string literal, I'll pass a pattern, an SQL pattern I mean. Let me set this up, so first I'll include a %, then STE and V, and another %. The % is the SQL wildcard specifier in a pattern that's used by a like clause in SQL. It means match on 0 or many characters. Java's regular expression specifier to do something similar, you'll remember, is a dot. Because I'm starting with a %, this will match the contiguous letters STEV in any part of the album name. I'll run that. You can see I get only 6 artists that match that. Most of them start with the first name, Steve, but there's also C6 Steve and Stevie Ray Vaughan. I could change my pattern if I wanted only artists whose names started with STEV by removing the first %. That would eliminate C6 Steve, which you can try on your own if you want to. JPQL doesn't eliminate the need to understand all SQL constructs, as this example demonstrates. In this code, you still needed to understand the like clause and valid patterns to use it effectively here. In addition to name parameters, you can use placement parameters in the query string. This is similar to the question mark placeholder which we saw in the prepared and callable statements. In this case, in addition to the question mark, you have to include a numeric value. Numeric placeholder specifiers must start at 1, but they don't have to be in sequential order, and you can reuse a numeric placeholder in a single JPQL string. I'll change my getArtistPLQL method, replacing colon matched value with a question mark followed by the number 1. I'll next change the setParameter method, passing in the number 1 as the first argument. If I run the code this way, I'll get the same results as I did with a named parameter. Named placeholders make more readable code, in my opinion, but it's up to you, or maybe the framework you're using, which kind of placeholder type you'll use. In this video, I've given you your first taste of using JPQL with a very simple select statement. The first brought back all data for all records, and the second query brought back all data for a limited set of records matching criteria on the artist name. I'll end this video here before it gets too long. In the next video, I'll continue using this project and this class's method and show you slightly more complex JPQL queries, so let's move on to that video.